Yesterday we started talking about key features of linear functions, or the different parts of a graph that makes a line. All right. We talked about the slope, how slanted a line is, and whether or not it's positive or negative. We talked about zeros, which is just the x value of the x-intercept. And we talked about intercepts, both the x and the y. Quickly, before we go on to what we're going to discuss today, I want to go over again what intercepts are. Intercepts are where a graph touches an axis. That would make the x-intercept where a graph touches the x-axis. The y value at that point, and it doesn't matter where it's touching the x-axis, the y value at that point is always 0, because the x-axis is where y equals 0. For the y-intercept, wherever the graph is touching the y-axis is the y-intercept, and for the y-intercept, the x value is always 0. Doesn't matter where it's touching the y-axis, that x number is always 0. Let's go over a graph like we talked about yesterday. So here we have a graph drawn with our y and x-intercept labeled. Here's our x-intercept where the graph touches the x-axis. Now it doesn't matter what this x number is. I mean, it's a positive number. It could be 1, 2, 3, it could be 4, 5, 6, 7, I don't know. That x number is going to go here when we write out what the ordered pair of the x-intercept is. The y value is going to be 0. The y value anywhere along the x-axis is always 0. So if you don't have a graph, you would still be able to find the x-intercept because you're looking for where the y would be 0. So the opposite is true with the y-intercept. The y-intercept is where it's touching the y-axis. Wherever the y, or wherever it's touching the y-axis, that x number is always 0. Doesn't matter. Any point along this y-axis is where x is equal to 0. And so again, if I needed to find the y-intercept without having a graph, I would know that that is the point or the number where x is 0. It would be that y value. So let's try that. Let's talk about what happens with the table, a mapping, or a set of ordered pairs. So if I'm looking for the x-intercept on a table, that means I want to find the point where my y value is 0. All right, that is my x-intercept. That is where the graph would be touching the x-axis. So looking at here, trying to find my x-intercept, I'm not going to look at the x column. I'm going to look at the opposite one. I'm going to look at the y column and see where y is 0. So looking down, I see that here is where y is 0. So this would be the x-intercept. If I were to graph it, then it would touch the x-axis at positive 2. All right, so I know that this is my x-intercept because the y value is 0. For the y-intercept, I'm not going to look at the y-axis, I'm going to look at the x-axis. So I want you to take a second or two, look at it, and see what point do you think would be the y-intercept in this table. So again, we're looking for the y-intercept. The y-intercept is where our x value is 0. So I'm going to look at the x column, try to find where x is 0, right here. And I know that this point, or this y value, is the y-intercept. Because no matter where it touches the y-axis, the x value is always going to be 0. So right here would be my y-intercept. So I can find my y-intercept or my x-intercept by looking at any table or mapping or set of ordered pairs just by finding where the zeros are. If there's a 0 for the x, then that's my y-intercept. If there's a 0 for the y, that's my x-intercept. What about when we have an equation? Sometimes you won't get a table or a graph or a set of ordered pairs or a mapping, but you'll be given equations where you have to figure out what your y and x-intercepts are. So I'm going to use this equation here to find the x and the y-intercept. Now this equation is just like the table that we just talked about. That's where I got these points, is from this equation. All right, so we're going to end up with the same y and the same x-intercept. But I want to show you how you can get it mathematically. So let's start with the x-intercept. For the x-intercept, whenever we're looking for that, what characteristic do we know about the y value? That it's 0, right? So we know that our y number is 0 whenever we're looking for the x-intercept. So I'm going to take the y out and put a 0 in its place. And now it just becomes a solving problem where I'm trying to get x by itself to figure out what the x-intercept is. So here I would add 4 to both sides. Crosses out. 4 equals 2x. Now I want to divide by the number that's in front of x, which is 2. And I end up with 2 for my answer for x. All right. That means that my x-intercept would be at the point 2, 0, which is exactly what we got when we looked at the table a couple of minutes ago. Right here, our x-intercept was at 2, 0, because it's where the y value is 0. It's where the y value is 0. We did the math, ended up with the same thing. So we can get it either way, looking at a table or mapping, or by using the equation. For the y-intercept, now I want to make my x value 0. So I'm going to take the x out of the problem, put a 0 in its place, and then do the math to figure out what that would equal. So y equals 2, and now my 0 is going to go right here for x. 2 times 0 minus 4. Well, 2 times 0, anything times 0 is 0. 0 minus 4, and then finally I have y equals negative 4, which again, going back to our table, is exactly what we got for the y-intercept, the 0.04, where the x is 0. So the point for my y-intercept would be 0, negative 4. So I can find these doing it algebraically through the equation, or if I have the table or mapping available, I can still find my x-intercept. So there's no reason why we cannot find the x or y-intercepts even without a graph to look at.